This video is going to cover the second page of the Chapter 3 test, version 1. And so make sure that the first question that you're being asked on your version is that angle 2 is congruent to angle 9. Okay. So what you're supposed to do in this exercise is look at the given information and decide whether or not that information tells you that lines are parallel or not. So we had a list of reasons how to make lines parallel in a proof. We could prove that corresponding angles were congruent, or alternate interior angles were congruent, or same side interior angles were supplementary. Let's see what we've got with angle 2 being congruent to angle 9. Okay. Now take a look. 2 and 9 are both touching the same line. They are both touching, let's see, line C. So I'm going to highlight that for you. Extend it a little bit. And so that should be my transversal. Now what is being transversed here? We've got line A and line B. What kind of angles could you refer to angle 2 and angle 9 as? Well, they're inside A and B, so I call those interior, and they're on opposite sides of line C, so I would call that alternate. If you put it together, we've got alternate interior angles. Alternate interior angles being congruent is one of our reasons that we can make lines parallel. So we're going to say that A is parallel to B because alternate interior angles being congruent is a way to prove that lines are parallel. I'll erase all our markings, so that we can start fresh on B here. In B, we are told that angle 3 is congruent. Let's see. Angle 3 is congruent to angle 11. Okay. So what line are they both touching? Both of those angles are touching C. I'm going to highlight that for you. Now, what two lines is C crossing that are involved in angle 3 and angle 11? Well, let's see. That would be here and here. 3 and 11 are formed by both the purple line and a green line. Now, if you look at these two angles, they're in the same position relative to where the green and the purple cross. We call those angles corresponding. And hopefully you remember from your list that, let's change back to black here, because corresponding angles are congruent is a way to prove that lines are parallel. We just have to preface that statement with the parallel lines. The parallel lines are in green here, so we're going to say that E is parallel to F. Let's start over. Measure of angle 1 and 4 are equal. So here's 1, here's 4. So the first thing I've been asking in each of these previous examples was, what line is both angles touching? Are both angles touching? I don't see a line that's touching both of these. So they aren't connected by one transversal, so there's really no relationship there. Now, if we knew that A and B were parallel and E and F were parallel to one another, then we could figure some things out about a relationship between angle 1 and angle 4, but we don't know that. 1 and 4 on its own can't prove parallel lines. So I'm going to erase those marks, and I get to just put a quick none in letter C. And then I move on to letter D, where it says angle 8 plus angle 5 plus angle 6 gives me a sum of 180. Okay. Now the 180 is a big hint here, because we only had certain types of angles that were supplementary. Alternate interiors out, correspondings out. We had same side interior, same side exterior. So hopefully you're anticipating that. So let's see, where's 8? Here's 8. I'll mark that. And then 5 and 6, they happen to be connected, so I can go ahead and write or mark the angles together like this. Okay, now, what line do they share? What could be their transversal? Well, looks like they're both touching line B. Now, what line is B, or what two lines are crossed by line B that make angle 8 and angle 5 plus 6 together? Well, let's see, that would be E and F. Okay. Now, looking at that diagram, we notice that the two angles that I've marked, 8 and then 5 plus 6, are inside the parallel lines, or at least lines that we think are parallel, which are E and F. Okay. And they are on the same side of the transversal, so if they're same side and inside, same side interior, we know same side interior is supposed to be supplementary. So we can say with confidence that E is parallel to F because same side interior angles are supplementary, proves that lines are parallel. I'm going to move down to number 5, which may or may not be number 5 on your version, depending on which version you took, but we are still on the second page. And we're told that 7 interior angles of a nonagon, a 9-sided polygon, have the following measures. The remaining 2 angles are congruent. What is the measure of one of the remaining angles? Okay. Well, it would be really good to know what the sum of the measures of interior angles for a nonagon are. So hopefully this pops into your head, this formula, n minus 2 times 180. Okay. For this particular situation, our n is 9. There's 9 sides in this polygon. 9 minus 2 times 180 degrees. Okay. And how would we get that? Well, this is angle 1, 2, 3, 4, 5, 6, 7. Okay. The remaining 2 angles are congruent. So that's going to be 8 and 9. We don't know what that measurement is, so we'll call it x. But the nice thing is that since they are congruent, I can call both 8x and 9x. So we got to write all those angles out. 140, 132, 167, 141, 157, 100, 129. And then don't forget about these guys, x and x, which make 2x. Simplifying that, 7 times 180 gives me 1260, or 1,260 degrees in a nonagon. All these constants add up to 966, and then we've got 2x. Subtracting the 966 from both sides gives us 294, and then dividing out 2 on both sides gives us an x value of 147 degrees. So the 2 missing angles must be 147 degrees. That concludes this video.